respected committee members of IAPT Deenabandhu Sahu Memorial Award and the listeners, I, Dr. DADAMIAH PMD SHAIK, giving a presentation as a part of IAPT Deenabandhu Sahu Memorial Award 2025. My presentation includes about myself, my classroom session, my work and my achievements. My education from the highest degree, I have completed my PhD in 2016 from Sri Venkateswara University, Tirupati, under the supervision of Professor O. Muhammad Hussain. The thesis title, Investigations on Nanocrystalline Bulk and Thin Film Manganese Oxide Electrodes for Supercapacitor Applications. And I secured first class in pre-PhD examinations. My PG in Physics with Condensed Matter Physics specialization from Sri Venkateswara University, Tirupati, and secured 82.5%, for which I received a gold medal from the university in 2007. My UG with Physics and Computer Science specialization from Sri Krishnadevaraya University, Anantapur, and secured 82%, stood second in the university. My experience, I have 19 years of teaching experience in various reputed degree and engineering colleges. Currently, I am working at Vardhaman College of Engineering, Hyderabad, as Associate Professor and Head of the Department of Physics since 2023. Prior to that, I worked at Lord's Institute of Engineering and Technology from 2020 to 2023 for 3 years. I worked at Sri Vidyaniketan Engineering College as Assistant Professor in Senior Scale from 2012 to 2020 for 8 years. I worked at Sri Venkateswara College of Engineering as Assistant Professor from 2007 to 2012 for 5 years. And I worked at Sri Venkateswara Degree College, Kadapa, from 2006 to 2007 as a lecturer for 1 year. My research from 2010 to till date, I have published 23 articles in reputed journals, 3 conference publications, 3 books and 1 book chapter, 2 patents. 1 patent is granted last year. The other patent also completed hearing. I am guiding one student from Career Point University, and I have completed 3 projects from various funding agencies, DST, IISc and SVET. My classroom session, I have chosen Hall effect as a topic, as it is one of the physics phenomena discovered by E.H. Hall in 1879. It states that when a current carrying conductor or a semiconductor placed in a magnetic field perpendicularly, then a voltage is developed in the direction perpendicular to both current and magnetic field. The statement can be represented in a form of a diagram. Let me take a 3-dimensional sample. If we pass current along x direction and apply the magnetic field along z direction, then voltage must develop along y direction. So current, magnetic field and voltage. The developed voltage called Hall voltage. So this is the simplest way of representing Hall effect in a diagrammatical form. Now let us understand what is the physics behind in the development of the Hall voltage. For which, let me consider a conductor sample where electrons are the charged carriers having 3 dimensions x, y and z with L, B and T as length, breadth and thickness. In absence of external electric field, these electrons move randomly and hence net current is 0. But according to Hall, the voltage is developed across the current carrying conductor after applying the magnetic field perpendicularly. So we have to get current through this conductor, which is possible by applying external electric field. If I apply external electric field in x direction, then it forces the charged carriers in its opposite direction if they are negative charges, in the same direction if they are positive charges. As conductor contains negative charges, the force by the electric field acts in its opposite direction. So the electrons move from random direction to the single direction, which results current through this conductor, and we call this as drift current, and this phenomena as a drift. And the current moves along the direction of x, which is opposite to the direction of electrons, and the electrons acquire a constant velocity, which we call drift velocity. And now we have a current carrying conductor. We should apply magnetic field to it in perpendicular to the current. Assume we are applying in the direction of z. Now this magnetic field forces the charged carriers. The force by the magnetic field onto the charged carriers depends on Fleming left hand rule. According to Fleming, if we keep our 3 fingers of left hand perpendicular to each other, namely middle finger, forefinger and thumb, if the direction of current shows by the middle finger, then the direction of forefinger shows by magnetic field. The force by the magnetic field onto the charged carriers indicates in the direction of thumb. Now if you apply this to our case, the current is in the direction of middle finger and the magnetic field in the direction of forefinger. The force act in the direction of thumb, means downwards. Because of that force, the electrons turn to the bottom face, by which the bottom face will act with a negative potential, and compared to that, the opposite face, that's top face, will act with positive potential. And now if I connect external voltmeter between top and bottom faces, which shows the deflection in it, and it is the reason, it is the results of developing Hall voltage. The development of the Hall voltage proves the Hall effect, from which the Hall field is also develops between the 2 faces, top and bottom faces, and we denote it with EH. And now the mechanism here, the Hall field, once it develops, it also forces the charged carriers in its opposite direction. Now the magnetic field force is acting in downwards, the Hall field is acting in upward direction. At equilibrium, both the forces are balanced. By applying that condition, we can get the expression for Hall voltage and understand on what parameters this Hall voltage depends. Now at equilibrium, force by the Hall field is equals to force by the magnetic field. Force by the Hall field can be written in terms of EH is equals to force by the magnetic field EVD into B. As drift velocity and magnetic field are perpendicular to each other, so we get VD cross B and VD B sin theta, and theta is 90, so sin theta becomes 1. Now E gets cancelled, we can write the Hall field as VH by the distance between the 2 faces, top and bottom, we have taken it as a thickness, is equals to Vd drift velocity, and there is a relation between drift velocity and current density. J is equals to NEVD. From this we can write Vd is equals to J by Ne. Now let me substitute J by Ne in place of Vd, B as it is. Now we can write expression for Vh is equals to 1 by Ne into J into B and into T. The next, in place of 1 by Ne, a new parameter is introduced, namely Hall coefficient RH, J into B into T. So this is the expression for Hall voltage, and which shows the Hall voltage depends on Hall coefficient, current density, applied magnetic field and the thickness of the sample. Now the Hall voltage Vh can be written in terms of current RH into current density as current per unit area. The area of the surface we can write B into T, magnetic field into thickness of the sample. So T gets cancelled. Now as Hall voltage depends on Hall coefficient, I am writing the expression for Hall coefficient, RH is equals to B by B into Vh by I. From this equation we can find the Hall coefficient by substituting the B, the distance between the two faces of the sample, by knowing the dimensions that we can substitute, magnetic field, how much we are applying to the sample, so that if we keeps a constant, then the Hall coefficient depends on the current and Hall voltage. In laboratory, the students pass current through the given sample and they measure Hall voltage, for which they understood the Hall effect is verified. Then at different Hall probe current, they note down the Hall voltage values, which will be a straight line passing through origin, and the slope of this curve they will substitute in this formula. After substitution, they found the Hall coefficient of the given sample. If it is a conductor, then the Hall coefficient is negative and is in order of 10 power minus 10 to 10 power minus 11 meter cube per coulomb. If it is a semiconductor sample, the Hall coefficient is negative for N-type semiconductor and it is positive for P-type semiconductor, and the Hall coefficient in order of 10 power minus 3 to 10 power minus 4 meter cube per coulomb for semiconductors. For intrinsic semiconductors, the Hall coefficient is positive because the electron mobility is more than hole mobility. And this is how the students they calculate the Hall coefficient and identify a type of a given semiconductor. And using this RH equation, where RH is equals to 1 by Ne, and from this N is equals to 1 by RHE, where RH is Hall coefficient, E is the charge of the electron, and we can substitute Hall coefficient, by which we can find the carrier concentration of the given sample. If it is a conductor, it comes in order of 10 power 28 to 29 meter per meter cube. If it is a semiconductor, the carrier concentration will be in order of 10 power 19 per meter cube. So these are the applications of the Hall effect. One, identifying the type of semiconductor; the other, finding the carrier concentration of the given either semiconductor or conductor. In addition, we can also measure the conductivity of the sample, mobility of the charged carriers, magnetic fields, and power dissipation from the electric circuits. These are all the applications of the Hall effect. With this, my work starts in evaluating the students. The major work as a teacher, giving classes to the students, at the same time evaluating the students. From the day one, they are continuously evaluated. In the beginning, with a diagnostic test, the students will be evaluated, and those who got less than benchmark, those who got more than benchmark will be given different tasks. Those who got less than benchmark, for them a special attention is given. The classes separately will be taken. Those who got more than benchmark, for them we will assign some NPTEL courses to complete, or the projects will be assigned in the beginning of the semester, so that these advanced students will focus on completing their projects. These projects, after the semester, they come with a very good result, and that will be exhibited in Science Day celebrations or in any other project exhibitions. Due to this practice, one of my students also got a cash prize of 1 lakh in 2024 recently. And the students who got less than benchmark, they will be monitored till mid-1 examinations, and if they continue still, then they will be given a remedial classes, and their academics will be improved slowly, so that they also complete the course. This is how the students' evaluation is, which is a very challenging task for a teacher, and finally the output should come. All the students must clear the course and must go with a very good physics background, so that helps them in other courses as a prerequisites. If they are good, they understand electronic devices, circuits, basic electrical engineering, and electromagnetic theory concepts very easily if they are good at physics. This is how the classroom and the assessment is continuous after the curriculum design based on the industrial approach. So that is continuous process. And my achievements, I received Best Teacher Award from Lord's Institute of Engineering Technology in 2022 for my contribution towards the physics domain, as I used to conduct talent hunts, so that the students for first year they involve, and those talent hunts helps them in improving their physical science skills and physical knowledge, and that is how they also presented in national level competition at Osmania University and grabbed the prizes. And Best Paper Award in 2022 by presenting a paper in 3rd International Conference in 2022, and a diamond certificate from Mohan Babu University in 2022, who conducted a FDP on familiarization, patent filing, and grants. Then I ratified as Associate Professor from Osmania University and Assistant Professor ratification from JNTU Anantapur and JNTU Hyderabad. And I have completed a course by name Solid State Physics in NPTEL, and also a light and silver certificate I received conducted by ISER Bhopal in 2021. And I am one of the Board of Studies members and chairperson at Lord's Institute of Engineering Technology, and also Board of Studies subject expert into engineering colleges in Hyderabad. Best Researcher Paper Award from Sri Venkateswara Educational Trust, Vidyaniketan Educational Trust, and state eligibility test I have cleared for both Andhra Pradesh and Telangana states, which was conducted by Osmania University in 2015, and received gold medal, as I have already mentioned, from the university where I have studied PhD and PG. With this, I acknowledge all my teachers and my Guru Dr. O. Muhammad Hussain for his knowledge transfer, and our principal Dr. J.V.R. Ravindra, who nominated me as one of the nominees for this prestigious award, IAPT Deenabandhu Sahu Memorial Award 2025. Thank you very much.